Okay, now we're going to look at continued fractions. And my favorite little fun phrase from my high school math teacher, split, flip, and rat. Remember that?
Yep.
Okay. So a continued fraction is a fraction of the form, an integer, I'll call it a, plus 1 over b, plus 1 over c, plus 1 over d, on and on and on. Well, on and on and on. Sometimes they stop, sometimes they go on forever.
Yeah.
Okay? And we're going to look at when they stop and when they go on forever. So let's look at a simple example. Give me a fraction where the top is bigger than the bottom. You can pick any numbers you want.
3 halves.
Okay, let's pick both numbers bigger than 10.
Okay, 13 twelfths.
13 twelfths. I'm going to pick 23 seventeenths.
Okay.
Okay? 23 over 17. This is 1 plus how many seventeenths?
Well, you have to subtract 23 minus 17. It's 6. 6 seventeenths.
Okay, 1 plus 6 seventeenths. Very good. Do you agree?
Yeah.
Okay. Now I flip this over, so I make 6 seventeenths equals 1 over what?
17 6.
17 6. Very good. Okay. 1 over 17 6. And what is 17 6 as a integer plus a fraction?
It's 2 and 5/6.
Now I flip 5 6 over.
6/5. And 6/5 is 1 and a 5th.
Hey, now we're done. Right? Because I have 1 plus 1 over plus 1 plus 1 over plus 1 plus 1 over. So 23 seventeenths goes to 1 plus 1 over 2 plus 1 over 1 plus 1 over 5. Pretty interesting, right?
Yeah.
Any rational fraction, 2 integers, is going to end in a finite number of steps.
Yep.
And that's because, and I should have pointed this out more, the fractions get smaller as you go along.
Yep.
Okay. What did we have? We had 1 plus
6 seventeenths.
6 seventeenths, and when I flip that over, I got 17 sixths. Notice that 17 was smaller than 23.
Yep.
And 6 was smaller than 17, and that happens all the way down. Now let's do square root of 2 and do our split, flip, and rat, because we only split and flipped in this one.
Yep.
Square root of 2, how do I split that into an integer plus a non-integer?
Well, it's 1 plus 1 minus the square root of 2. We don't really know what it is.
Hold on. It's not 1 plus 1 minus the square root of 2.
The
Because
square root of 2 minus 1.
There you go. The square root of 2 minus 1. Okay. Do you see why this side adds up to the square root of 2?
Yeah.
Okay. Do you remember the square root of 2 was about 1.41 something?
Yeah.
So it's an integer, 1, plus the non-integer part. Okay, that's a little tricky to see. Do you understand that?
Yep.
You do? Okay, good. Now I do the same thing. I flip this, so I get 1 plus 1 over the square root of 2 minus 1. Where did this 1 over the square root of 2 minus 1 come from?
Well, you flipped this fraction over. Because the square root of 2 minus 1 you can write as a fraction and put over 1 on the bottom.
Yeah.
So you flipped it over.
I flipped it over. Rat now means rationalize. I want to change this. We don't like square roots and denominators of fractions, so how do I get rid of it? Do you remember? This is a tricky part.
Well, if you multiply by the square root of 2, it cancels. But that doesn't... Multiply by the square root of 2 over the square root of 2.
Okay, well let's see what happens when I multiply by the square root of 2 over the square root of 2. What do I get on the top?
You get the square root of 2.
What do I get on the bottom?
Well, So the square root of 2 squares.
And I get 2 when I multiply this.
The square root of 2 it's minus the square root of 2.
Shoot, so that didn't quite get rid of it.
So we'll have to do it again.
Here. We gotta find something clever to multiply by to get rid of the square root on the
What
bottom.
about the square root of 2 plus 1?
Aha! Square root of 2 plus 1.
Or the square root of 2 plus 1.
Okay, so now I get the square root of 2 minus 1 times the square root of 2 plus 1, which is a special kind of multiplication called what?
It's a quadratic.
Well, it will be a quadratic, but I have x minus y times x plus y,
It's a difference of squares.
which is our old friend,
The difference of
the
squares.
difference of squares. Okay, so x squared minus y squared. Okay? So when I do this multiplication on the top, I get square root of 2 plus 1. And on the bottom, what do I get?
Well, you get 2,
Yeah?
and then you have minus the square root of 2 plus the square root of 2
Yep.
minus 1.
Okay, so I'm left with what?
The square root of 2, well, you left with 2 plus 1, 2 minus 1, which is 1.
So I'm left with 1 on the bottom. And square root of 2 plus 1 on the top, which is just square root of 2 plus 1, right?
Yeah.
Okay, now how do now I go back, split, flip, and wrap. Now split, square root of 2 plus 1, what does that turn into? What is the integer part of that?
It's 2 because you have the 1 from the square root of 2
Yeah?
plus this one.
Uh-huh.
So 2 plus the square root of 2 minus 1.
The square root of 2 minus 1. Where have we seen the square root of 2 minus 1 before?
Up there.
Up here.
So this is
Remember that?
Yeah.
Now we flip it over. 1 over the square root of 2 minus 1. What does 1 over the square root of 2 minus 1 turn into?
1 over the square root of 2 minus 1.
What did we do last time?
Well, we
We rationalized it by multiplying by what?
square root of 2 plus 1.
Square root of 2 plus 1 over square root of 2 plus 1, and that turned it into
A difference of
a
squares.
difference of squares. And 1 over the square root of 2 minus 1 turned into what fraction? What number? Do you remember?
it was the square root of 2 plus 1.
Plus 1. Square root of 2 plus 1. Remember that?
Yeah. But
So then
that's
we-
the number we got before.
That's the number we got before.
We're going to get 1 plus 1 over 2 plus 1 over 2, etc.
It's just going to keep going forever. It keeps repeating.
So it's irrational.
So this will be an infinite continued fraction. But I said if it was rational, it would stop.
Well,
But
that
it
means
doesn't
it's
stop.
not.
That doesn't stop. But here's the amazing thing. In this continued fraction form, the square root of 2 is a perfectly nice number. 1 plus 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2. Right?
Yeah.
In its decimal form, 1.414, whatever, it doesn't repeat. There's no obvious pattern in these digits.
Yeah.
But representing it this way, you get a really nice number. It just happens to go on forever.
Yeah.
But that means,
The pattern keeps going.
well, what does it mean that it goes on forever?
It's irrational.
It's irrational. Totally different way of looking at it.
Whoa.
Pretty neat though, right?
Yeah.
Alright guys, there's 4 different proofs that the square root of 2 is irrational. This what we'll call the standard proof, one from geometry, one from number theory, and one involving continued fractions. All different ways of looking at it. Was this fun?
Yeah.
Alright. Alright, good job guys.